Okay, good morning, everybody. Sorry that I can't be with you today. I have to travel to Indiana, so I'll be on a plane all day and won't be back till Friday. So I'm really sorry that I couldn't be with you in person, but I wanted to go ahead and record a new lecture for this year for you. So just as a reminder, your livestock production assignment is going to be due this coming Monday. So make sure that you have that in by 11:59 p.m. And if you have any questions about that, feel free to email me. The plan for Monday is to do an exam review. If you have any questions before then please let me know, and then we'll talk about that next lecture. So today we're going to be talking about aquaculture, and it's a pretty short lecture today, so it's not going to be super long, but I'll go ahead and jump right into it. And again, sorry that I couldn't be with you live, but if you have any questions, please email me as you prepare for the test. So, and just before I get started, this will be the last chapter that will actually be on your test. So just to give you a little introduction to what aquaculture actually is, there are 3 different sources of fish and shellfish that could be raised in commercial landings, like also called captures or catches. This includes aquaculture, that is also called mariculture, and then recreational fishing are all sources of how we get fish that we eat, and any other kind of seafood that we eat. So the National Oceanic and Atmospheric Administration defines aquaculture as the propagation and rearing of aquatic organisms in controlled or selected environments for any commercial, recreational, or public purpose. So I'm not going to ask you to know like that long definition. Just be familiar with what aquaculture is based on that definition, but you're not going to have to like repeat it verbatim. So aquaculture includes the production of freshwater, brackish water, and seawater species, the latter called marine aquaculture or mariculture. So that would be your seawater species, so any sort of aquaculture that's taking place in the ocean. So aquaculture species can be categorized as either finfish, which would be your vertebrates, which mean they have a backbone, or shellfish, which would include crustaceans and mollusks. So those would kind of be the ones, obviously, that have more of a shell. So a little bit about the domestication of certain aquaculture species. So carp and Nile tilapia were domesticated in the Fertile Crescent, that same area where a lot of domestication took place, over 2,000 years ago. And aquaculture systems were actually developed to raise these fish. Even way back then, they had these aquaculture systems that they used. So most species that are produced today in freshwater aquaculture situations, and virtually all of those that are in marine aquaculture, so again, marine aquaculture is seawater, were domesticated in your or your parents' lifetime. So there were some species that were domesticated a long time ago, but most of the species that we're familiar with today were kind of produced here recently. So aquaculture is very important globally. There is a growing consumer demand, and that therefore there's a problem of overfishing. So there is a need for aquaculture because aquaculture can raise more fish in a central area. It kind of cuts down the need to go overfish certain areas because you can more effectively manage fish in a certain area when you're kind of doing it in an aquaculture type production system. So many species that are now raised by aquaculture, with many domesticated in the 20th century, so not all that long ago. So in 9 years, freshwater or inland aquaculture has grown by 90.4%. So that's a really, really high rate of growth for aquaculture. And marine aquaculture has grown by 98.2%. So these are definitely kind of a growing field, and they're extremely important when we talk about animal production or, production of fish and seafood. So aquaculture produces over 95% of carp and oysters that we eat, over 70% of salmon, trout, and tilapia, and over 40% of shrimp. So these would be, aquaculture would be considering the production systems that are not like people out in the ocean kind of catching their own things. These are raised in a specific type of aquacultural production system. So carp are the #1 group of species raised by aquaculture, and China is the largest carp producer, which actually I've always heard that carp didn't taste that good. So that kind of surprises me that that's the #1 group of species, but it is. So China is the #1 country for aquaculture production and exports. So again, China is a really big player globally for a lot of these species. Aquaculture in the U.S. Grosses about $1.06 billion annually. And again, that number is probably a little bit dated. It's probably more now. So there is still opportunity for the industry to grow. The U.S. is a major importer of shellfish and finfish. So remember, shellfish are kind of like mollusks and crustaceans and things like that. And then your finfish are going to be your vertebrates, or the ones that have a backbone. There is a growing consumer demand for fish. I think we hit on that a little bit later, kind of what's driving that. And catfish and shellfish production is increasing. So these are just a couple of pictures of some fish farms. And as you can see here, on the top left, you have kind of a like dry land situation where you've got these big tubs or pools of water that are actually housing the fish. And probably in this situation, these would all be the same species. Like this could be maybe like a salmon farm or something like that. But some situations you may have different ones at the same area. I've actually been to a research facility for the company that I work for that does some stuff with aquaculture, and they actually have like different tubs, and they have different species in almost every tub because they do research with them. They're not actually raising them for food. But then on the bottom, so this would be kind of a mariculture situation. It looks like that's in the ocean. So these are kind of segmented areas where different species would be contained. So this would be in a certain area of the ocean where you can have that seawater situation and still have the right environment for the fish. And so just to give you an idea of how big these are, I don't know if you can see this very well, but you can see the little guy in the boat down there feeding the fish. So now we're going to talk a little bit about fish nutrition. So we've talked about a lot of the other species and how they have a fairly complex digestive system. So fish are going to be a little bit more simple. So not all of the digestive system components that we've talked about before are present in all fish. So they require a very high quality feed with easily digestible proteins, such as fish meal. So actually a feedstuff fish meal that's been made from other fish and then kind of like ground up and dried into this fish meal that's a very, very good source of digestible protein. Sometimes we actually feed it to pigs and other animals. But so it's really, really good for aquaculture purposes. However, it's kind of expensive. So fish are extremely efficient at growing on very little feed. So they have a gain to feed ratio of almost 1. So that would mean that for every pound of feed they get, they're converting that into a pound of meat. So they're extremely efficient. So for example, a pig, typically what we look at for their gain to feed is that it takes about 2.5 pounds of feed to put on 1 pound of meat for a pig. So you can kind of compare that to fish and see that they're extremely efficient. So they grow really well with very little input. So if you have better feed, then that means you'll have better nutrient absorption because it's a better quality feed. You'll have less nutrients that are being wasted, and that will lead to cleaner water. So just in this picture here, so you can kind of see what their digestive system looks like. You have their mouth, and then the gills, and then they have what is called an oesophagus, which is just kind of a really, really short esophagus. It's not like the long one that you've seen in some of the other animals that we've talked about. And then you have the stomach, and then the ceca right there, and then this is all the intestine, and then you have the reticulum, and then the primary kidney. So it's a pretty simple system compared to some of the other animals that we've talked about. So now we're going to move on to fish reproduction. There are a lot of different ways that fish can actually reproduce, and it really varies depending on the type and species of fish. So most fish will typically lay a large number of eggs, and typically these eggs are going to be fertilized internally, and then they'll be scattered outside of the body. And so many shore fish or shore and freshwater fish will actually lay eggs on the bottom among the plants so that they won't be disturbed and they kind of know where they are. Because obviously if they kind of just laid them in the water, they would kind of get dispersed everywhere. So they kind of tuck them under some plants. And there are actually some fish that have live young. So they do not lay eggs. They actually have live young that kind of come out and are pretty much ready to go. And so an example of those would be sharks. So a little bit more about fish reproduction, which I think is kind of cool. So some fish are actually what we call hermaphrodites. And so what this means is that some fish actually have both male and female sex organs and characteristics. So that means that some fish can actually produce both sperm and eggs. So it's very different than some species where you have a male and a female, one produces sperm, one produces eggs, and they have to join together. Some fish can actually produce both. So be familiar with this term because it's bolded, it's underlined, so it's going to be important. Sequential hermaphrodites, which is another thing that I think is just very, very cool, because it's very interesting and not a whole lot of animals have this, is when a fish can actually start off as one sex or gender and then switch to the other if the need arises. So why would they want to do that? So a good example is if the breeding member of one sex is removed by death or other means, like if it's caught by a fisherman or something, or if it dies, then an animal that is one sex can actually shift to the other sex to kind of balance that out so that they can continue to reproduce and go on. And so that's called sequential because it kind of happens in a sequence. So you have the regular hermaphrodites where they're kind of born with both, and then you have some fish that are sequential hermaphrodites, which is just a type of hermaphrodite where they can change their sex throughout their lifetime based on the need kind of in their environment. So be familiar with this slide. It's a good slide to know. Hermaphrodites is obviously a vocabulary word I'd like you to know. So just be familiar with that. So as I talked about, there has been a large consumer demand for fish, and that demand keeps rising. And there are a lot of different reasons for that. A lot of people are getting more health conscious, I think, than maybe in the past. Because America has a really high obesity rate, so it's kind of a big thing these days. People are kind of trying to be healthier. So what are the health benefits of consuming fish? Why are people so into fish? So fish is actually the only food that supplies large amounts of omega-3 fatty acids. So you may have heard of these before. I know some people will take like fish oil supplements or things like that. So basically, omega-3 fatty acids are just a type of fatty acid. They're called omega-3s because of their structure. And so these are really important because they actually can cut the risk of heart attack and stroke significantly, and they may also elevate mood and help prevent certain cancers. So there's been a lot of research done on omega-3 fatty acids, and it has shown that they're very, very beneficial to your health. So if you want to get a lot of these, consuming fish is a really good way to do it. Consuming salmon and sardines are really good choices, and that's mainly because they're low in mercury, which we're going to talk about in a second. And so farmed fish is typically better than wild fish because many wild species have high levels of PCBs, which are kind of a toxic thing that you really don't want to consume. So you definitely want to kind of get farmed fish if you can. So we just talked about some health benefits of consuming fish, and so now I want to talk about some health risks of consuming fish. So mercury is a really, really big concern. So some fish are really high in mercury, such as the king mackerel, swordfish, sharks, and sometimes tuna, and sometimes it's underlined there because you'll see in a minute it kind of depends on what type of tuna you're eating. I'm a big tuna fan, so I kind of worry about this sometimes because mercury can be kind of a big deal. So I kind of try to limit the amount of tuna I eat, but I really like it a lot. So mercury can actually harm the nervous system of a fetus or young child. So this is extremely important, especially for pregnant women to consider. So pregnant women or women who are nursing or women who may become pregnant, I know I sound like one of those commercials for like a medicine right now, should take extra precautions when they're consuming mercury or consuming fish because it has mercury in it. And then contaminants such as dioxins and polychlorobipheноls, which are the PCBs that I mentioned on the previous slide, those compounds are linked to some cancers as well as reproductive problems. So it's just something to be aware that if you are thinking about having a kid anytime soon, or if you are already pregnant, you may want to limit your intake of fish and seafood. So this is just kind of a chart just to give you an idea of which fish species are kind of in which category for mercury. I'm not going to ask you to memorize this or like know any of where these fall. This is more just for your own information. So as you can see in the high category, you have your like bluefish, grouper, your mackerels, marlin, sea bass, shark, swordfish, and then tuna. But as you see in parentheses, that would be your big eye, ahi, canned albacore, or yellowfin tuna would be really, really high. So then in your moderate, you have bass, carp, cod, croaker, lobster would fall under moderate, and then you also have tuna again in the moderate category, and this would be like your canned chunk light or skipjack tuna. So again, you can eat tuna and not really be too worried about it, but you kind of need to know which type of tuna you're consuming and how much, because you don't want to eat too much of the tunas in the high category, or any of them in the high category, really. I just kind of harp on tuna because that's the one I eat a lot of. And then in the low tuna or low mercury category, you have like anchovies, catfish, clams, flounder, kind of all the fish that we're more familiar with getting at the restaurant or something like that, especially like oysters, catfish, crab, flounder, shrimp, all of those. Salmon are relatively low in mercury. So that's why salmon is a really good fish to eat whenever you're trying to be really healthy, because you can get the high amount of omega-3s with the low amounts of mercury. So it's kind of ideal. So other things to be aware of with aquaculture is that there are infectious diseases, and then because of that, there comes to be a food safety concerns. So there are considerable problems with infectious diseases in aquaculture species, and there are relatively few FDA-approved drugs for aquaculture species. So that could be why they have more of a problem with infectious disease, because they don't have that many drugs readily available that they can actually treat them with compared to other species like cattle and pigs and poultry. So antibiotics are used in aquaculture to treat disease, but not as a growth promoter, which I also like to just point out that they're not used as a growth promoter in any animal now. They've been removed as growth promoters by the FDA last year. So higher levels of organochlorine compounds, including those PCBs that we talked about, and dioxins in farmed versus wild salmon. So they've actually, typically as far as like mercury levels, it's better to get a farmed fish. However, sometimes in farmed salmon, you might actually see these higher levels of PCBs and dioxins. So now we'll just talk a little bit about catfish. So U.S. catfish production is mainly located in Mississippi, Alabama, Arkansas, and Louisiana, so primarily in the South. They're raised in large rectangular ponds that are considerably larger than a football field. So if you just think about that for a second, that is a rather large pond full of catfish. They're intensively raised in raceways with high flows of water. So they're going to be raised in a situation that mimics what their environment would be naturally, so that they can grow at a good rate. So the catfish female will produce anywhere between 3,000 and 50,000 eggs in a single egg mass. So that is huge. That is a lot of eggs, especially if they're on the 50,000 into the spectrum. So you can see why they're raised in such large pools, because that could get out of hand very quickly. Eggs are spawned in the spring when water temperatures are above 70 degrees, and the embryos will hatch after about 4 to 6 days, so it doesn't take very long at all. Hybrid catfish are commercially available in the U.S., and so these hybrid catfish, like we talked about hybrid vigor before, there are claims that these hybrid catfish have higher growth rates, improved feed efficiency, and greater resistance to disease. So again, there's that word hybrid, kind of better than the original parents. Now we'll talk a little bit about catfish food quality, food safety, and disease. So in farm-raised catfish, you may have sort of off flavors like an earthy or musty flavor, and this could just be due to the environment that they're raised in. Listeria monocytogenes and other foodborne pathogens have been isolated from channel catfish, so basically just pathogens and diseases to be aware of. And infectious diseases are responsible for $50 to $7 million in annual losses to catfish producers in the U.S. So that's a substantial amount of losses to aquaculture just through infectious disease. So if you're thinking about ever getting into like catfish farming, which I actually know someone who does that, beware of infectious disease and try to prevent it when you can. Other aquaculture species that are raised in the U.S. are the yellow perch, which is in this top right picture. So the market size for yellow perch is actually much smaller than other aquaculture fin fish species, so other fish that have a backbone. So they don't have to get quite as big before they're sent to market. Walleyes are another fish, which are on the bottom right in this on the slide. They're another one that's raised in aquaculture in the U.S., and there is potential for expansion of aquaculture production, and that could be to supply fish for sport fishing and also for food fish markets. So the future of aquaculture looks pretty good. There's a growing demand for fish and growing demand for other seafood. So the future looks good. It will probably keep growing. Selection and population genetics are used to develop species that will have improved growth rates and other performance traits such as disease resistance. So like every other livestock species that we've talked about, genetics are always working to develop species that can grow more efficiently and have better resistance to disease, but especially with aquaculture, like we said, because infectious diseases are such a big deal, it's really important in this particular area. So the progress that will come in aquaculture is going to be likely through interspecies hybrids. So again, like those catfish hybrids that we talked about that are said to grow faster and have better feed conversions and better gain to feed, better growth rate. Those are hybrids of like two different species of catfish. So that is where the progress will most likely be made, would be with those hybrid animals. So that is all I have for today. I know that that was pretty short. So just take some time, take the rest of the class time that you get off free to maybe start studying for the test or finish your livestock assignment. And then, of course, email me if you have any questions at all. And I will be posting information about the test dates for online students. Obviously, the test will open up next Wednesday for them, and it'll go for a week. So plan accordingly. For online students, I know that there was maybe one or two of you that had trouble getting to a testing center last time. Please let me know if you need to take the test at a different location so that I can make sure that everybody's proctor is set up and straight and ready to go and has the password. If I don't hear from you, I'm assuming you're taking it at one of the campuses, and everyone at the campuses should have the password. So again, get with me if any of that information has changed or you need to set up a proctor for this exam. So with that, I hope y'all have a good day, and I will see you on Monday for the exam review.